So this question is unique. We haven't seen one like this. This one is asking us to solve for both x and y. So we're going to have to actually do a couple of things. The first thing we should do is set up an equation where we know two pieces. And I can see right here that I have two vertical angles. So let me mark my vertical angles. We have this angle and this angle. And we know that vertical angles are congruent. So I can set these two equal to each other. And if I do that, I have an x in this and an x in this. So I have an equation that has one variable in it. So I can solve that. All right, so I'm going to do that first. I'm going to say that 5x is equal to 2x plus 30. And those two angles are equal because they're vertical. And so then I'm just going to solve. I'm going to subtract 2x. And I'm going to get 3x is equal to, that goes away, 30. And then you divide by 3 on both sides, and you get that x is equal to 10. Okay, so now we know what x is. That answers this part of the question. So x is equal to 10. That answers part of the question. All right, so now let's get ready to answer the other part of the question where we solve for y. Well, how is this angle, where x is, and this angle, where y is, related? How are those two angles related? Together, they make this straight line. So they are a linear pair. They are attached or adjacent angles that together make 180. So they're adjacent and they're supplementary. They make 180. So I know that if I add these two things together, I need to get 180. But if you write 5x plus y equals 180, we don't really have a way to solve an equation that has two variables in it. So I need to try and get rid of one of those variables. Well, I know that x is equal to 10. So I can take this 10 and plug it in right here. 5 times 10 is 50. So now, instead of 5x, I can actually erase that, and I can change it to a 50 because I know that 5x is equal to 50. And now I can solve for y. I can subtract 50 from both sides, and I can get that y is equal to 130. So now I have a value for x and a value for y.